Again.
Okay, thanks a lot. My name is Mark Russell. I work for the MITRE Corporation. We are a nonprofit that operates research and development centers for the U.S. federal government. My colleague Mike Peck was going to give this talk, but he sends his regrets. So we've been working on profiles of OAuth and OpenID Connect for enterprise use cases. That includes the government agencies that we work for, but really we don't want to create a U.S. government specific profile because we need products to implement it, and it's not a good use of taxpayer money to create government specific standards and then have to pay for custom integration. What we'd really like to do is meet the government's requirements in a way that aligns with how industry is handling enterprise use cases. So what we've done is we've defined some assumptions about the enterprise environment and use cases. We've reviewed the standards themselves, OAuth and OpenID Connect, and other existing profiles like FAPI and iGov. We've done some lab testing of products to ensure that what we're recommending can actually be implemented. And we've been identifying security concerns by looking at a lot of existing research and academic papers. And lastly, we've been discussing our requirements with subject matter experts and vendors, which is what brings me here today. So on this slide, you can see a summary of how we're describing the enterprise environment. First off, unlike in a social media or consumer web use case, the user is not really the resource owner. It's the enterprise that owns the data and services. Just as a side note, some of the people we talk to get really hung up on the OAuth use of the term resource owner. They tend to associate it with a data owner or application owner, basically someone who's involved in approving access to things. So we have to try to convince them that the resource owner is really just an ordinary user who might have access to something. It may be a suggestion for future versions of the specifications that, a different name for this character, the resource owner, maybe should be considered, because it doesn't seem to me like ownership of the resource is really a core concept to what we're doing with OAuth. Secondly, the enterprise has a public key infrastructure. U.S. government in particular has a very well-established PKI. They use client certificate authentication extensively, both for machines and for human users. The enterprise uses attribute-based access control, including attributes of both person entities and non-person entities. In allowing access to data, the authorizations of both the person and the system they're using need to be taken into account. And finally, there's a need to interoperate with partner enterprises, exchange data, and basically be able to interact in electronic fashion. So on this slide, you'll see the typical OAuth use case, but maybe with some terminology that's tailored to the enterprise world I've been describing. So a user is interacting with the client and needs to access a protected resource. The user authenticates to the authorization server using PKI or some other authenticator. There's growing interest in FIDO and other multi-factor for users who don't participate in the PKI. So the client gets an access token, protected resource, can make an access decision that takes into account the user's identity and that of the client, and then potentially other information like the form of authenticator that was used at the authorization server. But another difference here is that there may be an enterprise authorization policy in play. The RS may reach out to an authorization service, and there may be other policies involved. So simply having an access token doesn't necessarily guarantee that access to the resource will be granted. So the enterprise use cases we're looking at are delegation of authorization to a web app, delegation to a native app. Those are both OAuth use cases. And then federated user authentication to a web app using OpenID Connect. Implementing OAuth and OpenID Connect offers some clear benefits in the enterprise. We can avoid having to do user impersonation to backend resources. And as I've talked about, authorization policies can take into account both the user and the client identities. Finally, the ability to support different authentication methods without having to change the individual protected applications themselves makes it easy for us to adjust to new authentication technologies and requirements as they come up. So these are some of the concerns we wanted to address in our OAuth profile. I think most of these are not unique to the enterprise environment. First, beyond RFC 6749, there's a large number of specs to read and understand in order to get a good grasp on how everything works in the OAuth ecosystem. There are lots of options in the specifications that can add complexity, can hinder interoperability, and there are a lot of choices that implementers can make that can have security implications that might not be clear to them as they're building out their design. We've been really happy to hear about OAuth 2.1, and we think that specification moving forward is going to help simplify a lot of these things for us. Next, there's a lot of concern over bearer tokens. We've been tracking the efforts over time to get to a better method of having trust that the token is being used by the authorized party. Things like mutual TLS, depop, and then the ill-fated token binding, which seemed like a great idea, but maybe has fizzled out. We hear a lot of concerns about client secret authentication. It's replayable. It relies on managing shared secrets, both things we'd like to avoid. In the base OAuth spec, there's no standardization of the structure and format of access tokens themselves, which probably makes sense in the realm of the web, but inside the enterprise, we can do useful things if we know what's inside the access token. And finally, the security of the protocols relies heavily on a proper TLS implementation. There have been lots of issues with bugs in TLS libraries, the potential for stolen or illegitimately issued certificates, and then some organizations doing break and inspect for security monitoring, which interferes with some of TLS's security guarantees and can introduce problems with certificate validation. So all these concerns together and the desire for interoperability led us to the need for profiling to help address some of those concerns. The profiles are also useful because they help us communicate with vendors and developers to give them a detailed view of what we want to be able to do and why we want it. We leveraged some existing work in building our profiles. There's obviously the FAPI profiles. We looked at the iGov profiles, which have a long heritage going back actually to when Justin Richer was at MITRE. We looked at the IETF's OAuth working group security recommendations, including the security BCP. And we went through some academic research on attacks and countermeasures like the mix-up attacks and other things that have been written about. So essentially, we've written and actually publicly released enterprise profiles for OAuth 2 and OpenID Connect. This slide just gives a brief breakdown of what's in the profiles. It's basically what you'd expect. It's requirements for the different participants and a bit of rationale for the decisions that were made. There is a link at the end of this presentation to the profile. So if you'd like to take a look and share any feedback, we would welcome that. This slide, which may be hard to read, gives some highlights of what's in the OAuth profile. So you're looking at the basic OAuth authorization code flow with some call outs for things that are required at different stages in the profile. First off, we only allow the authorization code and client credentials grants. So there's no implicit or resource owner password credentials. I think that's in line with mainstream security guidance. We require the use of the state parameter and also PXE, even for confidential clients, to add some protection for code interception attacks. There's strict redirect URI checking. One thing that may be more unique is in order to take advantage of the enterprise PKI, we require confidential clients to use client TLS authentication at the AS and the protected resource and use certificate-bound access tokens instead of bearer tokens. And finally, access tokens are required to be signed JSON Web Tokens. So we have a defined format. So some of the other profile requirements, we're requiring protected resources to only trust tokens from a single authorization server. In a lot of enterprises, there's a complex identity and access management system, and we want to leverage any sort of complexity there in the IDAM systems and keep things simple for the protected resources themselves, rather than have them have to mediate interactions with multiple authorization servers. There's one kind of well-tested IDAM system where we can handle some of the more complex stuff, and there are many protected resources, all unique individually, having to integrate. So there's a lot more room for error, I believe, on the protected resource side. Also, that helps us avoid the mix-up attack issues. We require the ability for the authorization server to disable consent prompts, since in an enterprise setting, the resource is generally not the user's data anyway. It's not like you're allowing the client to access your own social media account. And the prompts tend to get in the way of users trying to do their jobs. There's a lot more emphasis on streamlining the workflow rather than asking permission for highly trusted apps. We would like the ability to require specific strength of authentication at the AS, and also produce audit logs of all token issuance. So having completed the basic OAuth and OpenID Connect profiles, what we're working on now is what we call token chaining, which is basically a more complex interaction where the protected resource might need to call another protected resource. That resource might need to call another one, and so on, in order to satisfy a request from the user. So the left side of this picture is the basic OAuth flow with the user, the client, and the protected resource, which we're calling A. But then A, in order to fulfill the request, needs to call a different PR, which we call B. Our profiles require audience-constrained tokens. So A can't just replay the access token it got from the client at B. That kind of unconstrained token passing seems like it would invite all kinds of security problems. So instead, we want A to get its own access token to access B. And if B needs to access C, it should have its own access token, and so on. In this picture, we're looking inside a single security domain, and all the protected resources trust the same authorization server. So for this scenario, we're looking at token exchange, RFC 8693, for this use case. Basically, it provides a method for each protected resource to get its own access token that reflects all the actors in the scope of this request, including the user, the client, and all the protected resources in that chain. So all those identities can be considered in making an access decision. In the top right, there's an example of how you could have multiple ACT claims, which is short for actor, nested in the access token to show the full chain of entities involved in servicing the request. This is important in some environments because, for example, A and C might be authorized to handle a certain type of information that B is not authorized for. C needs to know that in order to determine the releasability of information back through that chain of systems. So we've written a token chaining profile that basically profiles OAuth token exchange for this specific use case. We're still testing this, and probably will make refinements as we try to do this in the lab. But that seems like it's doable. But now, what happens when those protected resources are in different security domains, each with their own authorization server? This is a requirement we have, so we need to make the same kind of token chaining work in this scenario. So currently, we're looking at a couple of different approaches here. You could use token exchange, but that specification was really written with the assumption that there's only one authorization server involved, that A would get a token from its authorization server, and B would, also trust that same authorization server. Here we've got 3 different ASs. So one thing you could do is A could request a token from B's authorization server. Otherwise, A could get a token from its own authorization server, and then B has to trust it, even though it came from a different authorization server. Or maybe B can pass off the token to its AS using introspection, and perhaps the AS could validate the access token, maybe using some back channel to the other authorization server. what we're finding is there are different trade-offs and challenges with all of these approaches. For one thing, ideally, we'd like to avoid having the protected resources have to register themselves as clients in multiple domains. As I said earlier, we'd like to have each protected resource only trust access tokens from a single AS, so that would sort of compromise that position. If possible, we'd like to handle that complexity in the authorization server and the other IDAM services supporting the protected resources. Keep things simple for the protected resource, which ideally only needs to know about its own IDAM system. Another thing we're looking at here is the JOT assertion grant for this scenario. So it seems like that was designed and maybe more suited for cross-domain use cases. So in that approach, A could exchange its initial access token that it got from the client for a JOT that would be acceptable for use at B's authorization server, using the assertion grant to get its own access token. So then A would have an access token issued by B's authorization server to present to B. This involves an extra step with the additional token exchange. And the assertion grant specification doesn't say anything about the actor claim, which was really a useful construct for us in the token exchange standard. So we're still mulling over the different approaches. Definitely interested in talking to anyone else who's working these kinds of use cases and hearing about your experiences. So in terms of next steps, we're looking to do more testing analysis. We are looking at OAuth 2.1 and FAPI 2.0. We'd like to reference as much of those profiles as we can to simplify our own profiles and get better alignment with the direction of mainstream industry. Also, we're interested in talking to anyone else who's facing similar challenges, enterprise use cases, the chaining use cases, and interoperability challenges. We've got our contact information on the last slide, and please reach out if you'd like to talk to us. And that's all I had. I think I'm finishing early. I guess we can open it up for questions.
Thank you, Mark. Are there any questions in the participants? Anyone wants to ask anything? Now is the time. Also, the same as last talk, if you have some topics that are brought up by the talks, then please submit a session proposal for Thursday or Friday.
This is Thorsten speaking. Just a comment on something that you just said in the presentation. I don't think OAuth 2.1 will significantly reduce the number of RFCs that are relevant for OAuth, and that's why I also see a real need for the kind of profiles as you just presented, because every of those profiles represents the requirements of a certain domain or industry or something like that. I don't believe that's going to change.
No, I agree. I suppose what I really meant was we reduce the number of specifications that we need to pay attention to and read. But no, your point is well taken. I think there will still be a need for profiles.
Yeah, I mean, as a co-author of OAuth 2.1, I can tell you that what we're trying is we want to try to get rid of all the BCPs. So the BCP for SPA, the BCP for native apps, and the security BCP. I think that's what we can achieve. So everyone can safely assume if I read OAuth 2.1, then I have the current security guidelines for all kinds of application in one place. I think that's a great improvement, but we did not consider to really fold into that MTLS and other new specification. I think it would be too early.
Yeah, that makes sense. And I think we're open to looking at alternatives. I know FAPI's looked at other methods of dealing with the bearer token issues. One of our requirements, though, is we want to specify things for which there's current software we can use today. So as additional features become supported in software, we'll likely be open to including other methods.
Yeah, I think that's a wise approach, and FAPI now also conversed on MTLS, so we removed the token binding because it just passed away in the end. And MTLS right now is the only viable mechanism that is available today. I hope Depop will see broad adoption, but it's still to be seen.